Now, in this lecture, we'll find out the value of angle x in two different methods. In the drawing, we have triangle PQR. We know that QS equals to SR. This angle PSR equals to 45 degrees. Angle PQR equals to 3x, and then angle PRQ equals to x, and we want to find out the value of angle x. So we'll start with the first method. In the first method, we will define angle PQPS as angle alpha. Then we will define angle SPR as beta. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if angle PSR equals to x, then if you look on the upper side of the straight line QR, then we get that 45 degrees plus the size of angle x must be equal to 180 degrees according to all the dimensions. So here we will subtract 45 degrees from this equation, and we will get that x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that angle x equals to 135 degrees. So we can substitute x by angle that is equals to 135 degrees. In the next step, I will present to you a new rule. It is actually the law of sines. The law of sines is applied in any triangle so actually if we have triangle we note that the length of this side is equals to a units, and the opposite sides, the opposite angle is angle A. And we also know that the length of this side is B, and the opposite angle is B. And we also know that the length of this side of the triangle is C, and the opposite angle is C. According to the law of sines, A over sine A equals to B over sine B equals to C over sine C. So from this formula we can derive that A over sine A equals to B over sine B here we will divide this equation by B and then we will multiply it by sinus A and we will get that A over B equals to sine A over sine B. So this formula means that actually the ratio of the side lengths of the triangle equals to the ratio between the opposite angles. Okay? Again, the ratio between the side lengths of the triangle, that is to say A over B, equals to the ratio between the opposite angles, that is to say it equals to sine A over sine B. Okay? So we return to our drawing. In our drawing, here we can write down that PS over QS equals to PS over SR. I repeat again. According to question number 1, PS over QS equals to PS over SR. This equation is true because of the fact that QS is equal to SR according to what is given us in the question. But according to the formula that we found, that the ratio between the side lengths of the triangle is equal to the ratio of the opposite angles, we will get that actually PS over QS, if we focus on triangle PQS, here PS over QS will be equal to sinus 3x over sinus alpha. And if we focus on triangle PSR, then PS over SR will be equal to sine X over sine beta. Okay. In the next step, we will focus on triangle PQS. We know that in triangle PQS, the sum of the angles is equal to 180 degrees, as it is in any triangle. So the sum of the angles in triangle PQS is equal to alpha plus 3x plus 45 degrees is equal to 180 degrees, because of the fact that the sum of the angles in triangle PQS must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees and 3x from equation number 2, and we will get that alpha equals to 180 degrees minus 3x plus 45 degrees likewise. If we focus on triangle PSR, this triangle, you know that the sum of the angles on triangle PSR is equal to 180 degrees. That is to say, beta plus 135 degrees plus angle x must be equal to 180 degrees. I'll repeat again. The sum of the angles in triangle PSR must be equal to 180 degrees. That is to say, beta plus 135 degrees plus angle x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from this equation number 3. We will get that angle beta equals to 45 degrees minus x. So we actually managed to express alpha and beta in terms of x. Now we will substitute alpha and beta in this equation number 1, by the values of alpha and beta from equation number 2 and equation number 3, and we will get one equation if only one variable that is missing, that is actually the angle x that we are looking for. Okay, so we substitute alpha and beta by the values that we got for alpha and beta in equation number 2 and equation number 3. So we get here that sine 3x according to equation number 1 over sine alpha, and we found out that alpha equals to 180 degrees minus 3x plus 45 degrees according to equation number 2. So we write it down. We substitute alpha by 180 degrees minus 3x plus 45 degrees, and it equals to sine x over sine beta, and we already found out that beta equals to 45 degrees minus x, so it is sine 45 degrees minus x. We know that sine 180 degrees, according to the trigonometric identity, that sine 180 degrees minus theta equals to sine theta. We have the trigonometric identity that states that sine 180 degrees minus theta equals to sine theta. So according to this trigonometric identity, we can substitute sine 180 degrees minus 3x plus 45 degrees by sine 3x plus 45 degrees. So we will do it now, and we will get that, according to equation number 1, sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. So here we will cross multiply equation number 1, and we will get that according to equation number 1, sine 3x times sine 45 degrees minus x equals to sine x times sine 3x plus 45 degrees so actually this is what we got after we cross multiplied equation number 1. Here we will multiply this equation number 1 by 2, and we will get that, according to equation number 1, two times sine 3x times sine 45 degrees minus x equals to 2 times sine x times sine 3x plus 45 degrees. So here we will use the trigonometric identity that states that 2 times sine A times sine B equals to cosine A minus B minus cosine A plus B. We will use this trigonometric identity in order to simplify equation number 1. Here, the trigonometric identity states that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. So in our equation, we will get that A equals to 3x, B equals to 45 degrees minus x, now we look only on this side of equation number 1. According to the trigonometric identity, we will get here that 2 sine 3x times sine 45 degrees minus x, it equals to cosine A minus B. Cosine A is 3x, B is 45 degrees minus x, so A minus B is 3x minus x is 4x, and it is actually minus 45 degrees. And minus cosine A plus B. 3x plus minus x is 2x plus 45 degrees. So we finished with this side of equation number 1. Now we will deal with this, the other side of equation number 1. The value of 2 sine x times sine 3x plus 45 degrees according to this trigonometric identity. Here we will get that A equals to x and B equals to 3x plus 45 degrees. So according to this trigonometric identity, we will get that 2 sine x sine 3x plus 45 degrees is equal to cosine A minus B is A is x, B is 3x plus 45 degrees, so A minus B is x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So in conclusion, we got that the first expression is cosine minus 2x plus 45 degrees, but we have the trigonometric identity that states that cosine minus x equals to cosine x. So we can substitute cosine minus 2x plus 45 degrees. We will change the sign from minus to plus because cosine minus x equals to cosine x. So it will be equal to cosine 2x plus 45 degrees. And then we will have also minus cosine A plus B. A is x, B is 3x plus 45 degrees, so A plus B is x plus x is 4x plus 45 degrees. Okay? So here we have we will add to this equation number 1, cosine 2x plus 45 degrees. So in this side of the equation we will have cosine 2 times cosine 2x plus 45 degrees, and we will add to this equation also cosine 4x plus 45 degrees. Okay, and we will get that according to equation number 1, we will get cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees it will be equal to 2 times cosine 2x plus 45 degrees. Okay, I'll repeat again. According to equation number 1, we got that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. Here, in order to simplify this side of equation number 1, we will use trigonometric identity. According to the trigonometric identity that we will use, cosine C plus cosine D equals to 2 times cosine C plus D over 2 times cosine C minus D over 2. I'll repeat again. In order to simplify this side of equation number 1, we will use this trigonometric identity that states that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And in order to simplify the other side of equation number 1, we will use, it is actually, as you can see here, cosine 2x plus 45 degrees. It is something that looks like cosine A plus B. So we will use the trigonometric identity for cosine A plus B. Actually, cosine A plus B equals to cosine A cosine B minus sine A times sine B. Okay? I'll repeat again. In order to simplify this expression, 2 cosine 2x plus 45 degrees, we will use the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A sine B. And from the expression on the other side of equation number 1, we will use the trigonometric identity that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. So we will start with cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees. Here we can see that C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So we will get that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, according to this trigonometric identity, it will be equal to 2 cosine C plus D over 2, 2 cosine C plus D over 2. C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C plus D, it is actually 4x plus 4x is 8x, and 8x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. So we left only the 4x, and it is times cosine C minus D over 2. So it is cosine C minus D. C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C minus D is 4x minus 4x is 0, and minus 45 degrees minus 45 degrees is 90 degrees. It is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But according to the trigonometric identity that cosine minus x equals to cosine x, we can write down that cosine minus 45 degrees equals to cosine 45 degrees. So in conclusion, in this side of equation number 1, we got this expression that 2 cosine 4x times cosine 45 degrees equals, here we have 2 cosine 2x plus 45 degrees. So here A will be equal to 2x, and B will be equal to 45 degrees. And according to the trigonometric identity for cosine A plus B, cosine A plus B equals to cosine A cosine B. That is to say, it equals to cosine A is 2x, so it is cosine 2x, times cosine B. B is 45 degrees, so it is cosine 45 degrees, minus sine A. A is 2x, so it is sine 2x, times sine B. B is 45 degrees, so it is sine 45 degrees. So here we will divide this equation, equation number 1, by 2 times cosine 45 degrees. We know that sinus 45 degrees equals to cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled, and here also 2 cosine 45 degrees will get cancelled, and here 2 sine 45 degrees will get cancelled because of the fact that sine 45 degrees equals to cosine 45 degrees. So what's left from equation number 1 after we cancelled 2 cosine 45 degrees? What is left? It is actually cosine 4x equals to cosine 2x minus sine 2x. Okay, we got question number 1 states that cosine 4x equals to cosine 2x minus sine 2x. We will add sine 2x to this equation, and then we will add sine 2x, and then we will subtract cosine 4x. Okay, and we will get that sine 2x equals to cosine 2x minus cosine 4x. We have the trigonometric identity that sine 2 alpha equals to 2 sine alpha cosine alpha. Therefore, sine 2x will be equal to 2 sine x cosine x. Here we have cosine 2x minus cosine 4x. We will use the trigonometric identity that states that cosine C minus cosine D cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. We will use this trigonometric identity in order to simplify the value of cosine 2x minus cosine 4x. Okay? So according to the trigonometric identity states that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2, and we have cosine 2x minus cosine 4x. So here C will be equal to 2x and D will be equal to 4x. And we'll get that cosine 2x minus cosine 4x, it is 2 sine D plus C over 2. That is to say, it equals to 2 sine D plus C. D is 4x and C is 2x, so it is 4x plus 2x is 6x, and 6x over 2 is 3x, times sine D minus C over 2. So it is sine D minus C over 2. D is 2x, and D is 4x, and C is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we found out that two sine x cosine x equals to 2 sine 3x times sine x. Here we will divide this equation number 1, by 2 sine x. So here 2 sine x will get cancelled, and here also 2 sine x will get cancelled. What is left from equation number 1 after we cancelled 2 sine x? What is left? It is actually cosine x equals to sine 3x. Cosine x equals to sine 3x. We have the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. So we will substitute, according to this trigonometric identity, we can substitute cosine x by sine 90 degrees minus x. So cosine x is sine 90 degrees minus x, and it equals to sine 3x. Here 9 minus x equals to 3x. You can see it. 9 minus x equals to 3x. 90 minus x equals to 3x. We will add x to this equation, and we will get that 90 degrees equals to 4x. We will divide this equation by 4, and we will get that the value of x is 90 over 4, that is to say it equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees. We finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. Okay? In the second method, we will define angle QPS as alpha, as we did in the first method. We will define angle SPR as beta. In the first method, we have already found out that angle PSR, this angle equals to 135 degrees, so I will not repeat on it. And we know that the sum of the angles in any triangle is equal to 180 degrees, so in triangle PQS, this triangle, we will get that alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. In triangle PQS, as it is true also in any other triangle, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. We will subtract 45 degrees from this equality, from this equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees, it equals to 135 degrees. So we got the equation number 1 that states that alpha plus 3x equals to 135 degrees. We will focus on triangle PSR. On triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, angle beta plus this angle that is 135 degrees plus this angle that is actually angle x must be equal to 180 degrees. I'll repeat again. In triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. We will subtract 135 degrees from this equation, equation number 2, and we will get that beta plus x equals to 180 degrees minus 135 degrees equals to 45 degrees. Here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 3 times 45 degrees is 135 degrees. According to equation number 1, alpha plus 3x equals to 135 degrees, and according to equation number 2, 3 beta plus 3x also equals to 135 degrees. So we can compare equation number 1 to equation number 2. That is to say, equation number 1 equals to equation number 2 because in both of them we have 135 degrees. Equation number 1 equals to equation number 2. So this will be equation number 3. Equation number 3 states that alpha plus 3x that equals to 135 degrees, according to equation number 1, must be equal to 3 beta plus 3x that also equals to 135 degrees, according to equation number 2. So we got the equation number 3 that says that alpha plus 3x equals to 3 beta plus 3x. We will subtract 3x from this equation, equation number 3, and we will get that alpha equals to 3 beta. So we found out that according to equation number 3, alpha equals to 3 beta. So here we will do a construction from point Q. We will draw a straight line to side PR. From point Q we will draw a straight line to side PR in such a way that this angle will be equal to x. We can do it. And we will define the point between the straight line from Q to side PR as M. So the straight line QM was drawn in such a way that angle RQM will be equal to X. We drew the straight line QM in such a way that angle MQR will be equal to X, but we know that angle PQR equals to 3X. It is given us in the question. So if angle PQR equals to 3X and angle MQR equals to X, then angle PQM must be equal to 2X, because X plus 3X, X plus 2X must be equal to 3X, yes? Okay. Here we will join. So here triangle MQR is an isosceles triangle. I'll repeat again. Triangle MQR, this triangle is an isosceles triangle because of the fact that it has two angles that are equal to each other. Both those two angles are equal to X. In the next step, we will join points M and S together by a straight line, and the base of the isosceles triangle, triangle QMR, is QR. So we will join points M and S together by a straight line. So actually, MS is the median to the base of the isosceles triangle, triangle MQR. Why MS is the median? Because of the fact that it bisects the base QR to two equal parts. It is given us in the question that QS equals to SR. So you can see here, QS equals to SR. It is given us in the question. Therefore, MS is the median to the base in the isosceles triangle, triangle MQR. And we have a rule, it is rule number 3, that states that the median to the base in an isosceles triangle is perpendicular to the base. So the median MS not only bisects the base QR into two equal parts, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees. This is the right angle, and this angle also equals to 90 degrees according to rule number 3, that states that the median to the base of an isosceles triangle perpendicular to the base. So the median MS to the base QR of the isosceles triangle QMR, it is not only bisects the base into two equal parts, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So here, so if we focus, we have actually a new rule. It is rule number 4. According to rule number 4, the exterior angle of a triangle the exterior angle of a triangle is equal to the sum of the two angles inside the triangle to the sum of the two angles that are not adjacent to it. I'll read rule number 4 again. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles inside the triangle that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have a triangle ABC, so this is triangle ABC. This is angle beta, this is angle alpha. So inside triangle ABC we have three angles, alpha, beta and gamma. And the exterior angle of triangle ABC is angle ACB. This is the exterior angle. And according to rule number 4, the exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. So what are the two angles that are not adjacent to this angle, angle SAB? Angle gamma is adjacent to angle SAB, so the two angles that are not adjacent are actually alpha and beta. Therefore, according to rule number 4, angle SAB equals to the sum of the two angles that are not adjacent to this angle. That is to say, it equals to alpha plus beta. Okay? So the exterior angle, angle SAB of triangle ABC equals to alpha plus beta. Okay? We can implement rule number 4 in our drawing, because in our drawing, if we focus on triangle QMR, the isosceles triangle, triangle QMR, this isosceles triangle, and this angle, angle QMP, is an exterior angle of the isosceles triangle, triangle QMR, and according to rule number 4, it equals to the sum of the angles inside the triangle that are not adjacent to it. The only two angles inside triangle QMR, the associated triangle QMR, that are not adjacent to this angle are x and x. That is to say, the exterior angle PMQ equals to x plus x, that is to say it equals to 2x. Okay? According to rule number 4, the exterior angle QMP of triangle QMR equals to the sum of the two angles that are not adjacent to angle PMQ, that is to say it equals to x plus x, that is to say it equals to 2x. So actually, in triangle PMQ, triangle PMQ is an isosceles triangle because of the fact that it has two angles that are equal to each other. That is to say, those two angles, they are both equal to 2x. Therefore, triangle PQM is an isosceles triangle. And we have the rule that in front of equal angles inside the triangle, we have equal sides. So in front of those two angles, we have equal sides. That is to say, PQ equals to PQ equals to PM. PQ equals to PM. So we found out that PQ equals to PM. I write it down. PQ equals to PM. And we will draw perpendicular from point P to QN, and we will extend it until it touches QS. So those two angles are right angles. We will define the touching point between the perpendicular to QS as N. And so here we define this angle, this side, this point is point L. We will focus on triangles PLQ, triangle PLQ, this triangle, and triangle PLM, this triangle. Okay, we will focus on those two triangles. Those two triangles have two right angles. Those two angles are right angles, therefore they are equal to each other. That is to say, angle PLQ is equal to angle PLM. And both angles are equal to 90 degrees. Okay? Angle PLQ equals to angle PLM, and both angles are equal to 90 degrees. Those two angles, they are equal to each other. They are both equal to 2x. Okay, so we can write down that angle PQL of of triangle PQL equals to angle PML, and both angles are equal to 2x. Okay, angle PQA equals to angle PML equals to 2x. So actually those two angles, they will be also equal to each other according to third angle theorem. Okay, so actually angle QPL, this angle, equals to angle MPL according to third angle theorem. I repeat again, angle QPL equals to angle MPL according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. Why? Because the third pair of angles are actually complementary to 180 degrees. Okay? So if we define this angle as theta, then this angle must be also equal to theta, and you can see from the drawing that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. So 2 theta equals to alpha plus beta. According to equation number 3, alpha equals to 3 beta. So we can substitute in this equation alpha by 3 beta, and we will get that 2 theta equals to alpha. Alpha is 3 beta. 3 beta plus beta is 4 beta, so we got that 2 theta equals to 4 beta. We divide this equation by 2 and we will get that theta equals to 2 beta. Theta equals to 2 beta. So we can write here that theta equals to 2 beta. Here also theta equals to 2 beta. But here, this angle is angle theta, and this angle is angle beta. And theta equals to 2 beta. So this angle equals to 2 beta, and this angle equals to beta. So this angle must be also equal to beta in order to that beta plus beta will be equal to theta. Okay? This angle must be also equal to beta because of the fact that beta plus beta equals to theta. Okay? So here we will focus. We found out that this angle equals to 90 degrees. This angle equals to 90 degrees. Angle MSQ equals to 90 degrees. And this angle is 45 degrees. So this angle must be equal to 45 degrees in order to complete the sum of the two angles to 90 degrees. Here, and this way we will get that 45 degrees plus 45 degrees equals to 90 degrees, and this angle is indeed 90 degrees. So this angle must be also equal to 45 degrees. So we will focus on triangle PNS and triangle PSM. I will draw it again. Okay, so we will focus on those two triangles, triangle PNS and also triangle PMS. On those two triangles, those two angles, they are equal to each other, they are both equal to beta. Angle NSP, this angle, and it is actually angle NPS, angle NPS equals to angle SPM, and they are both equal to beta. Those two angles, they are both equal to beta. PS is the common side. PS equals to PS is the common side that belongs to both triangles. Those two angles, they are both equal to 45 degrees. So we can write down that angle NSP equals to angle PSM, and both angles are equal to 45 degrees. So we actually proved that triangle PNS is congruent to triangle PSM, triangle PNS congruent, this is the sign of congruent, to triangle PMS according to angle side angle rule. Okay, we have those two angles in triangle PNS and the angle and the side that attached to them, that is say PS equals to those two angles and the side that attached to them in triangle PMS. Therefore, those two triangles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle can go into two angles and the side that included in another triangle, then the two triangles can go into each other according to angle side angle rule. And again, we proved that those two angles and the side between them, that is to say PS, in triangle PNS, can point to those two angles, and the side between them, that is to say PS, in triangle PMS. Therefore, we prove that those two triangles can point to each other according to angle side angle rule. And from the fact that those two triangles can point to each other, we will conclude that MS equals to NS. MS equals to NS. MS. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can point to each other. Therefore, the corresponding sides, that is to say NS and MS, will be equal to each other. Okay, NS equals to MS. So we can write here that NS is equals to MS. So we will join points M and N together by a straight line. Angle MSN is a right angle, it equals to 90 degrees. Okay, this angle is 90 degrees. So the other two angles in triangle MSN must be equal, the sum of them must be equal to 90 degrees, because of the fact that the sum of the angles in a triangle equals to 180 degrees. So this angle is 90 degrees, so the rest must be equal to 90 degrees. And we know that NS equals to MS. Therefore, those two angles must be also equal to each other. So if one angle is y, then the other angle must be equal to 2y. So 2y must be equal to 90 degrees. We divide this equation by 2 and we will get that y equals to 45 degrees. So we found out that this angle equals to 45 degrees, and this angle also equals to 45 degrees. So we can write here, actually angle MNS equals to 45 degrees. And this angle also equals to 45 degrees. Okay. And in the next step, we will prove that triangle PQN is congruent to triangle PNN. So I will draw the two triangles again. We have triangle PQN. Triangle PQN. Actually, it is triangle PQN congruent to triangle PMN. Okay, so we have here angle 2 beta, this angle is also 2 beta. So first of all, we know that PQ equals to PM because of the fact that those two angles, they are equal to each other, they are both equal to 2x, therefore in front of equal angles they are equal sides, that is to say PQ equals to PM, PQ equals to PM, yeah. PQ equals to PM. Those two angles, they are also equal to each other. Those two angles, they are also equal to each other. They equal to beta, so angle QPN equals to angle NPM. And they are equal to beta. And we have also a common side. PN is a common side, it belongs to both triangles, so PN equals to PN. It's a common side that belongs to both triangles. So we actually proved that those two triangles can go into each other according to side angle side rule. Triangle PQN congruent to triangle PMN according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you prove that those two triangles can go into each other according to side angle side rule. And we proved that those two sides and the angle between them in triangle PQN can go into those two sides and the angle between them in triangle PNM. Therefore, we proved that those two triangles can go into each other according to side angle side rule. Okay? And from the fact that those two triangles can go into each other, we conclude that QN equals to MN, QN equals to MN, okay, here QN equals to MN. See here QN equals to MN. If we join points Q and M together by a straight line, this angle equals to x. Angle MQN equals to x. Angle MQN equals to x. And we have the rule that states that in front of equal sides in the triangle there are equal angles. So those two sides are equal to each other, therefore In front of them we have also equal angles. Those two angles are in front of those two sides. That is to say, if this angle equals to x, then this angle must be also equal to x. So we found out that this angle also equals to x. Okay? This angle equals to x. And you can see that if we focus on triangle Q, on triangle Q and M, on the green triangle, then the size of angle, that is actually angle S and M, the exterior angle S and M, according to rule number 4, it equals to the sum of those two angles that are not adjacent to this angle. And the two angles that are not adjacent to this angle are x and x. That is to say, angle M and S equals to 2x according to rule number 4. Again, angle M and S equals to 2x according to rule number 4. I repeat again, angle M and S equals to 2x according to rule number 4. Angle M and S, the exterior angle of the green triangle, the exterior angle of the green triangle, triangle M and S, the exterior angle of the green triangle, triangle MQN, is angle M and S, and according to rule number 4, it equals to the sum of the two angles that are not adjacent to it, and the two angles that are not adjacent to it is x and x. That is to say, this angle M and S equals to 2x from one side, but from the other side we have already found out that angle M and S equals to 45 degrees. Angle M and S equals to 45 degrees. So angle M and S equals to, from one side, to 45 degrees, and from the other side it equals to 2x. From this equality we will conclude that 2x equals to 45 degrees. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2 is 22.5 degrees. So we found out that according to the second method, that angle x equals to 22.5 degrees. So we finished with the second method. In the next step, I will summarize the lecture. Okay? So we actually found out the value of angle x according to two methods. In the first method, I will repeat on the question. We have here triangle PQR. We know that angle PSQ, this angle equals to 45 degrees. we know that QS equals to SR. We also know that angle PQR equals to 3x, and angle PRQ equals to x, and we want to find out the value of angle x. So we actually defined this angle QPS as alpha, and we define this angle SPR as beta, and this angle equals to 45 degrees. It is given us in the question. QR is a straight line, and we know that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on point S, on the straight line QR on the upper side, the sum of the angles must be equal to 180 degrees. That is to say, 45 degrees plus this angle that we will define as angle X must be equal to 180 degrees. 45 degrees plus X equals to 180 degrees. We subtracted 45 degrees from this equation, and we got that angle X equals to 135 degrees. So we found out that this angle equals to 135 degrees. Then I presented to you the law of sines. The law of sines is true in any triangle. So if we have this triangle, you know that this angle is A, this angle is B, this angle is C. The length of this side is the length of this side is A, the length of this side is B, and the length of this side of the triangle is C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. So from this formula, we can derive that A over sine A equals to B over sine B. We will cross multiply this formula, and we will get that A over B equals to sine A over sine B. What does this formula mean? This formula means that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? So we can implement this rule in our triangle, in our drawing. First of all, we know that PS over QS equals to PS over QR. PS over QS equals to PS over SR. Again, PS over QS equals to PS over SR. Because of the fact that QS equals to SR, it is given us the question. So PS equals to, so PS over QS, according to the rule that I stated, that the ratio between the side lengths of a triangle equals to the ratio between the opposite angles. We will get that if we focus on triangle PQS, then PS over QS will be equal to sinus 3x over sinus alpha. PS over QS will be equal to sinus 3x over sinus alpha. And PS over SR, if we focus on triangle PSR, PS over SR will be equal to sinus x over sinus beta. Okay, PS over SR equals to sinus x over sinus beta. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PSQ, the sum of its angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 45 degrees and 3x from this equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Then if we focus on triangle PSR, the sum of the angles is equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. We subtracted 135 and also x from this equation number 3, and we got that beta equals to 45 degrees minus x. So after we found out the value of alpha and beta in terms of x, we can substitute alpha and beta in this equation number 1, by the value that we found for alpha and beta. So we did it here, and we got that sine 3x over sine, and instead of alpha, we got the value of alpha. We put the value of alpha according to equation number 2, and here we have sine x over sine beta, and beta equals to 45 degrees minus x, so we substituted beta by 45 degrees minus x, so we got this equation number 1, because, and we, according to the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, we get that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. Okay, and we got this equation. We cross multiply this equation, and we got this expression. Then we multiply this equation by 2, and we used the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B, in order to simplify the expressions here. And according to this trigonometric identity, we will get that 2 sine 3x sine 45 degrees minus x equals to 2 sine 4x minus 45 degrees minus cosine 2x plus 45 degrees. Then we treated this expression, and we simplified this expression according to this trigonometric identity, and according to this trigonometric identity, 2 sine x sine 3x plus 45 degrees equals to cosine 2x plus 45 degrees minus cosine 4x plus 45 degrees. Okay, then we arranged these expressions, and we got that cosine 4x minus 45 degrees equals to cosine 4x plus 45 degrees, and it equals to 2 cosine 2x plus 45 degrees. So we treated those two expressions according to the trigonometric identity that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And according to this trigonometric identity, we will get that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 cosine 4x times cosine 45 degrees. And here we have 2 cosine 2x plus 45 degrees. We treated this expression by using the trigonometric identity that cosine A plus B equals to cosine A times cosine B minus sine A times sine B. And according to this trigonometric identity, we got that this expression 2x times 2 cosine 2x plus 45 degrees equals to 2 cosine 2x times cosine 45 degrees minus 2 sine 2x times sine 45 degrees. We divided this equation number 1 by 2 cosine 45 degrees. Sine 45 degrees equals to cosine 45 degrees, and after we divided this equation by 2 cosine 45 degrees, we got that cosine 4x equals to cosine 2x minus sine 2x. We added sine 2x to this equation, and then we subtracted cosine 4x, and we got that sine 2x equals to cosine 2x minus cosine 4x. Sine 2x equals to 2 sine x cosine x, and cosine 2x minus cosine 4x equals to, according to this trigonometric identity, that cosine C minus cosine D equals to 2 sine d plus c over 2 times sine d minus c over 2. Here c equals to 2x, d equals to 4x. And according to this trigonometric identity, we got that 2 sine x cosine x equals to 2 sine 3x sine x. Then we divided this equation number 1 by 2 sine x, and we got that cosine x equals to sine 3x. And we have the trigonometric identity that cosine alpha equals to sine 90 minus alpha, therefore cosine x will be equal, according to this trigonometric identity, cosine x equals to sine 90 minus x. So we got that sine 90 minus x equals to sine 3x, that is to say 90 minus x equals to 3x. We added x to this equation and we got that 90 degrees equals to 4x. We divided this equation by 4 and we got that x equals to 90 over 4, that is to say x equals to 22.5 degrees. We finished with the first method. Then I presented to you how to find out the value of angle x according to the second method. According to the second method, we define this angle as alpha, this angle is beta. We have already found out that this angle equals to 135 degrees in the first method. Then we know that the sum of the angles in any triangle is equal to 180 degrees. The sum of the angles in triangle PSQ equals to 180 degrees, that is to say alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 45 degrees from this equation number 1, and we got that alpha plus 3x equals to 135 degrees. Then we focused on triangle PSR. On triangle PSR, the sum of the angles also equals to 180 degrees. That is to say beta plus 135 degrees plus x equals to 180 degrees. We subtracted 135 degrees from this equation number 2, and we got that beta plus x equals to 45 degrees. Then we multiplied the equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So equation number 1 has one side with 135 degrees, and the equation number 2 also have one side with 135 degrees. So we can say that equation number 1 equals to equation number 2. This will be equation number 3 that states that equation number 1 that equals to alpha plus 3x equals to equation number 2 that equals to 3 beta plus 3x. We subtracted 3x from this equation number 3, and we got that alpha equals to 3 beta. So according to equation number 3, alpha equals to 3 beta. Then I presented to you rule number 4. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles inside the triangle that are not adjacent to it. What is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC with angles alpha, beta, and gamma, the exterior angle of triangle ABC is angle SAB, and the value of this angle, the exterior angle SAB, is the sum of the two angles inside triangle ABC that are not adjacent to it. Angle gamma is adjacent to it, and the only two other angles that are not adjacent to it are alpha and beta. Therefore, according to rule number 4, the value of angle SAB, the exterior angle SAB, equals to alpha plus beta. And we can implement rule number 4 in our drawing. Here, actually, we made the construction from point Q. We drew a straight line here to point M in such a way, we build the straight line QM in such a way that this angle will be equal to x. Angle PQR in total it equals to 3x. So if this angle equals to x, then this angle must be equal to 2x, because 2x plus x is 3x. So if this angle is x, this angle must be equal to 2x. So here we created an isosceles triangle. Triangle QMR is an isosceles triangle, and why? Because it has two angles that are equal to each other, they are both equal to x, and the straight line MS is the median to the base of triangle, the isosceles triangle MQR. Why it is the median? Because it bisects the base QR into two equal parts. That is to say, SR equals to QS. And according to rule number 3, it is not only bisects the base, the median also is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? And then we implemented rule number 4 in triangle, the isosceles triangle QMR, we have two angles that are equal to x. And the exterior angle of the isosceles triangle QMR is angle QMP. The exterior angle QMP equals to the sum of the two angles that are not adjacent to it. That is to say, it equals to the sum of those two angles. That is to say, it equals to x plus x. That is to say, this angle QMP equals to 2x. So we have here 2x and 2x. It means that triangle QMP is an isosceles triangle, and in front of equal angles we have equal sides. That is to say, QP must be equal to PM because of the fact that those two angles are equal to each other, they are both equal to 2x. Okay, QP equals to PM. Okay, here PQ equals to PM. Then in triangle PLQ, PLQ and triangle PLM, we actually proved that those two triangles are similar to each other. We have angle PLQ equals to angle PLM equals to 90 degrees. Those two angles are both right angles, they are equal to each other. We have those two angles that are also equal to each other, they are both equal to 2x. Angle PQL equals to angle PML equals to 2x. So those two angles, they must equal to each other according to Faraday theorem. So if this angle is theta, then this angle also must be equal to theta. So from this drawing you can see easily that theta plus theta equals to alpha plus beta. Here, theta plus theta equals to alpha plus beta. That is to say, theta plus theta is 2 theta. 2 theta equals to alpha plus beta. But according to equation number 3, we've already found out that alpha equals to 3 beta. So here we can substitute alpha by 3 beta. And we got that 2 theta equals to alpha is 3 beta plus beta. So we got that 2 alpha equals to 4 beta. We divided this equation by 2. And we got that theta equals to 2 beta. Theta equals to 2 beta. So here, theta equals to 2 beta. This again is theta, it equals to 2 beta. This again is also theta, and it equals to 2 beta. Okay? Then we focus on those two triangles, and we actually proved the triangle PMS is congruent to triangle PNS. Okay? We proved that the green triangle PNS is congruent to the white triangle PMS. Why they congruent to each other? First of all, they have two angles that are equal to each other, they are both equal to beta. Angle NPS equals to angle SPM equals to beta. PS equals to PS, it is a common side that belongs to both triangles. And we have also those two angles, they are both equal to 45 degrees, therefore they are equal to each other. So we actually proved that those two triangles congruent to each other according to angle side angle rule. Therefore, we can conclude from it that NS equals to MS. NS equals to MS. So we know that this angle equals to 90 degrees. In triangle MNS, this angle equals to 90 degrees. So the other two angles must be equal to 90 degrees because the sum of the angles in any triangle is 180 degrees. So those two angles, they are both equal to each other from one side, and we also know from the other side that the sum of them is 90 degrees. So if we define one angle as y, then the other angle will be also equal to y. So we will get that y plus y, that is 2y, must be equal to 90 degrees. We will divide this equation by 2 and we will get that y equals to 45 degrees. So those two angles are equal to 45 degrees. Okay, so angle M and S equals to 45 degrees, that is to say angle M and S, this angle equals to 45 degrees. Okay, and then we proved that those two triangles can go into each other. Why they can go into each other? First of all, we have already found out that PM equals to PQ. You can see here, PM equals to PQ because of the fact that those two angles are both equal to 2x, and in front of equal angles they are equal sides. That is to say, PM equals to PQ. It is an isosceles triangle. PQM is an isosceles triangle. That is to say, PM equals to PQ. Okay, PM equals to PQ. Those two angles, they are both equal to each other. They are equal to 2 beta. Angle PQ equals to angle NPN to NPM equals to 2 beta. And we have PN is the common side, it belongs to both triangles, so PN equals to PN. So we actually proved that triangle PQN is congruent to triangle PMN according to side angle side rule, and from that fact we can conclude that MN equals to NQ. MN equals to NQ. Here, MN equals to NQ. MN equals to NQ. So here in the green triangle, the green triangle is an isosceles triangle because of the fact that MN equals to NQ. And we know that in front of equal sides in the triangle there are equal angles. That is to say, in front of those two sides we have two equal angles. That is to say, those two angles are equal to each other. But we constructed all this thing in such a way that this angle equals to x. So if this angle equals to x, then this angle must be also equal to x. Okay? So we have those two angles that are both equal to x. And if we focus on the green triangle, then M and S is an exterior angle of the triangle MQN. And according to rule number 4, the value of the exterior angle M and S equals to the sum of the two angles that are not adjacent to it. And the sum of the two angles that are not adjacent to angle M and S are those two angles, because this angle is adjacent to it. So the sum of those two angles is x plus x, that is to say it is 2x. So from one side, angle M and S equals to 2x, But from the other side, we have already found out that angle MNS equals to 45 degrees. Okay, from one side MNS equals to 2x according to rule number 4. From the other side, we have already found out that angle MNS equals to 45 degrees. Okay, from this equality we will get that 2x equals to 45 degrees. We will divide this equation by 2 and we will get that angle x equals to 22.5 degrees. So we found out in both methods that the value of angle x is 22.5 degrees. Okay, thank you very much.